The first speaker is Bob Langer, and Bob is the David H. Koch Institute Professor. And some of you may know that being an Institute Professor, there are 14 of them, I think, at the moment. It is the highest honor that the Institute provides to its faculty. I also want to just mention a few of Bob's many awards. Having to put the newsletter together for the department, I get to follow one of these, and it usually requires a fairly large Rolodex to keep track of them. But I think the key, some of the key ones, most recently, of course, is his National Medals of Science, his Millennium Technology Prize, the Prince Asturias Prize, they're also called the Spanish Nobel. And I won't take any more of Bob's time with these, but we're pleased that Bob can help us set its contributions in perspective.
Well, thank you very much. It's for me, it's a real honor to be able to present this talk. When Klaus first called me up, this is exactly what he asked me. I didn't make the title. I wasn't very creative. I didn't make the title up. Klaus said, could you talk about Ed Merrill and his contributions to the fields of polymer synthesis and biomedical engineering? And so, well, actually, whenever I get a task like this, about the history of something, actually, I've learned an important lesson. What I do is I call up my very, very good friend, Nick Pepis. And I ask him all kinds of questions. And so, and even though he's going to give the concluding talk, he's made enormous contributions to this one as well. And so I'll just start with a picture or two, but maybe just also to just give my own, how I first met Ed. I came to MIT in 1970 from Cornell, as actually a number of our speakers, Bob Cohn and Clark Colton also did. And I remember taking 1068, where Ed taught with Paul Flory's book, and 1069. And those were, I probably shouldn't say this for any of the other professors, but they may not still be alive that taught the other courses I took. But those were by far my most favorite courses. They were very, very inspiring to me. Ed was just a magnificent lecturer, as I'm sure everybody knows. But it really made me enjoy MIT. And the other courses I think I took were thermodynamics and mass transport and industrial chemistry. But polymer course was just terrific. And I really think to this day it's affected me all my life. And so here's just to show some pictures. This is actually three giants, Charles Draper, Ed, and Ed Gilliland, who I remember when I came to MIT, and you had to take the doctoral qualifying exam, everybody said this was, you didn't want to have Ed Gilliland ask you questions. He was, but actually anybody would have been hard, at least for me, anybody's questions would have been hard. But anyhow, this is just a very nice picture of a number of great people with Ed. And again, for those of you that were old enough to remember, this is where we all were. Now we're in this nice building. And actually, it's kind of funny when I go to different faculty meetings and things at MIT, people now want a much nicer building. But this, which is fine, we should get one. But when Ed was teaching and when I was a student, a lot of these other people, this was where we were. And I remember being actually right here in 12132, and I remember Ed's lab was, I was in Clark Colton's lab, Ed was across the hall. And then the other thing I actually remember very, very well is that downstairs about here, there was a ping pong room. And all of us got together and played ping pong. And that's actually how I got to know Mike Sefton, Nick Pepis, and lots of other people. Now, as I mentioned, my advisor was Clark Colton. And here's Clark. I don't know, is Clark here right now? I know he's coming later. Okay, well, it's okay. I won't. Then I can say all kinds of bad things. So at any rate, this is Clark at 24. And, of course, Klaus mentioned the academic tree, and you'll probably hear a lot about this today. But so Clark's advisor was Ed. And so in a way, like I always felt like I was Ed's kind of academic grandson, because he taught Clark and Clark taught me. And here actually is just some proof of this. This is Clark's thesis. Actually, you know, people would always kid me that I had a very long thesis. I think it was about 790 pages. But Clark would always remind me that it wasn't long enough because his was about 812 pages. He may tell you that today. So, and of course, Clark's advisors were Ken Smith, Ed Merrill, and Larry Evans, all of who've had, you know, magnificent careers. Glenn Williams was head of the graduate committee. And Ed also, as I mentioned, had wonderful students, many of whom would become my very close friends. Here's one of them. Now, at this particular point, now we could have a quiz about who this person is. He's got quite a lot of hair, very thin and stylish. And it's Nick Pepis, if those of you that don't know. He'll be speaking later today. And here's one of his, and I can even make fun of Nick when he is in the room. So no, I don't know what he'll say to me later. But at any rate, here's one of, and Nick and Ed wrote a number of terrific papers. Here's one of them. This is the development of semi-crystalline polyvinyl alcohol hydrogels for biomedical applications, and it was in the Journal of Biomedical Materials Research. And basically, it was on new ways of preparing them, where they might have use in a variety of biomedical applications like cartilage and membrane filtration and things like that. Now, this picture, actually, we could have even a better quiz. There's several people. I think this is Nick, right? But does anybody know who this is? Very good. Bob Cohn just got an A+. That's not an easy answer, but that is Mike Sefton, who will be speaking later today. You may also note that people in the 1970s had quite a lot of hair.
There's another one in the audience.
What's that?
Who is this guy here?
Right. Yeah, good. So anyhow, you know, we could have a very good quiz. I think now. This was actually terrific, and I remember Dave Terrell, who will be speaking later, was an undergraduate working there. Anyhow, it was just a very, very exciting time. I see. Bill was just talking about that we need to have a new method of hair reduction. So at any rate, one of the things that Nick and I looked at, just to try to give a flavor for Ed, and I'm going to actually look at my notes on some of these, is, you know, when you watch David Letterman, he always has like the top 10 things. So what we did is actually pick, and I'm going to do this in reverse order, starting with number 1, but the top 10 papers, just to give a feel for what Ed's done, is the top 10 papers of his as judged by impact factors. So we'll start actually with number 1. But I think what this will do is give you an idea of both the impact and also, I think, really the remarkable diversity of his contributions. So here's a paper actually in the Journal of Clinical Investigation, extremely high impact journal, in 1969, which has over 1,000 citations, which of course is a huge number of citations. And basically it was looking at the metabolic dependence of red blood cell deformity. And here, what he looked at was basically how ATP would affect this, and found that ATP really could help in terms of preserving red blood cell strength. And this paper, as I mentioned, has been cited a very, very large number of times. The second most cited paper is on the rheology of blood. This was in Physiological Reviews. And this paper also is a terrific paper. It basically analyzes just about everything you ever want to know about blood. And it basically talks about the basic data, hematocrits, fibrinogen, temperature, issues of abnormal blood, effects of different additives on blood rheology, blood of other mammals other than people, new kinds of blood tests, and so forth. And this has really become a very, very standard reference for people in the field. Number 3 is in macromolecules. And this is actually a more recent paper. by Susan Sophia, and this is in macromolecules, but it analyzes polyethylene oxide grafted onto silicone surfaces and how the grafting density affects protein absorption. And here what he's done is look at polyethylene oxide both in linear form and also in star form, and Ed's done a lot of interesting papers on that. He grafted it onto silicone surfaces and looked at protein absorption. He developed a new physical model for explaining how this works. Paper number 4. Actually, this is by Nick Pepys and Ed, and this is from the Journal of Polymer Science. And here, basically, they looked at polyvinyl alcohol hydrogels and how radiation cross-linking would affect crystallization. And they found a number of things, but in particular, what they learned from this is how by using cross-linking in the right way, they could make extremely strong hydrogels, and which would end up impacting their application in a number of different areas. Paper number 5, Ed wanted to try to address a puzzle. This is in Blood, also an extremely good journal, but this is, does the conformation of adsorbed fibrinogen dictate platelet interactions with artificial surfaces? And Ed finds actually that it does. He basically did a number of studies looking at adsorbed fibrinogen on these surfaces. He developed, with his students, different antibody probes to look at this, and basically found that and developed models for showing how surface coverage of absorbed fibrinogen would affect actually different platelet absorption and different interactions. The next paper was equilibrium modulus of model polydimethylsiloxane networks. Again, this is cited almost 300 times, and in Macromolecules, also an excellent journal. Here they looked at 12 different examples from the literature of how polydimethylsiloxane, what the modulus were. They developed the models to predict the behavior and showed that the models actually had a very good predictive ability in all 12 situations. The next one actually has a number of interesting authors on it. Pretender Verk, professor in our department, Ed Merrill, Harold Mickley, Ken Smith, and Dr. Mala Christensen. All, of course, these are all very, very distinguished people. And this addressed Tom's phenomena, which Pretender has done a lot of important work on. And Tom's phenomenon basically has to do with drag reduction. And here, basically, they looked at drag reduction in different types of pipe flows and different types of polymer solutions. And again, developed a lot of data and models on how this would work. The next paper, I think we're at number 8 now, was the rheology of hyaluronic acid. Hyaluronic acid is a glycoprotein. It's basically has sugars in it, and if you look at your a lot of things in your body, like your vitreous in your eye, that's mostly hyaluronic acid. And Ed, again, did a very, very detailed study of hyaluronic acid, looking at its viscoelastic properties, measuring them, and really understanding how they behaved under different situations. Paper number 9 was pressure flow relations of human blood and hollow fibers at low flow rates. And again, here he took red blood cells and examined the effects of tube surfaces and their curvatures and other parameters on how the red blood cell behaved. And the final one, which actually was alluded to actually in Klaus's mentioning of Ed, is gamma sterilization of ultra-high molecular weight polyethylene articular implants, and analysis of oxidation. Biomaterials, actually, at that time, Nick and I actually were the editors of it. And here, basically, what they were looking at was how gamma radiation affected and how the free radicals affected the stability of these polymers. And also, as was mentioned by Klaus, Ed also not only published all these papers, and actually many, many more, but also really pioneered, I think, in the education area, chemical engineering and medicine. Here, in addition to himself, he brought in Ken Smith, Ed Saltzman, Jerry Austin. Again, some of these people are also incredibly famous people in the medical area. Jerry Austin would later become a surgeon-in-chief at Mass General. Mel Glimpsher, who was head of orthopedic surgery over at Harvard Medical School. Judah Folkman, who was my postdoctoral advisor. It's kind of funny for me to see that he was in Boston City Hospital. He spent most of his life at Harvard. But these are all gigantic people. Andre Balazs, who did a tremendous amount of work on vitreous. But Ed really brought this in, and using Guyton's textbook, which is a standard textbook, and really brought this into engineering. And of course, today, while it seems, as Klaus mentioned, quite commonplace to have engineering in medicine, it sure wasn't in 1957. I can tell you, even in 1970, when I came to MIT, it was pretty uncommon. But Ed really pioneered not only scientifically, but educationally this area. So some statistics, and Klaus went over some of these, but I'll probably expand on this and perhaps give you more. But I think these statistics, to me, are really staggering if you think about the impact of one person and his descendants on these fields. So in addition to Ed, when the AICHE came out with their list of the 100 chemical engineers of the modern era, they not only picked Ed, but 8 of the people who worked with him. And actually, I should point out that that Ed's tree is pretty extensive, right? Because if, say, Ed taught Clark and Clark taught me, then I've taught people. If Ed taught Nick and Nick taught God knows how many people, or Mike Sefton, and it goes on and on. So the impact of Ed is pretty remarkable. But basically, eight of them, which is the largest number of any chemical engineer in the world. 15 of his former students and academic descendants have won national AICHE awards. These are 5 of the Colburn Award winners, which is the top chemical engineer under 35, 2 Professional Progress Award recipients, that's the top under 45, and 2 Walker recipients. And the latest academic tree, Nick must have updated Klaus's for him, because I only had 2945, and I think Klaus had 3,000. But the numbers are pretty high. But about 3,000 people with PhDs associated with him directly or through his academic descendants, through PhDs and postdoc positions. Also, of the 100 most cited biomaterial scientists in the world for all time, 68 are associated with his academic tree. That's a pretty remarkable accomplishment. 18 of the 20 highest-ranking chemical engineering departments in the United States have at least one faculty member that belongs to his tree. All 20 of the highest-ranked biomedical engineering departments in the U.S. have at least one faculty member that belongs to his tree. Over a 61-year career, Ed's been a pioneer in a number of fields of bioengineering. Klaus pointed to some of this too, but again, I think it bears repeating. He was the leading scientist in blood rheology. Those were several of the papers that I mentioned earlier in the 50s and 60s. In the 60s and 70s, he was a pioneer in the development of the artificial kidney, the analysis of its transport and the optimization of various kidney dialyzer membranes. And in the 60s and 80s, he pioneered protein-polymer interactions under stagnant and flow conditions, made remarkable contributions to the developments of hydrogels as biomaterials. You'll hear a lot about some of those contributions from people like Nick and Mike Sefton. He also made important contributions on ionic and covalent heparinization techniques and on polymer surfaces for antithrombogenic materials. He's been a pioneer, along with Ed Saltzman of actually Beth Israel, who proposed polyethylene oxide as a biocompatible material in a seminal 1979 paper and did significant studies to analyze its structure and blood response. In fact, Alan Hoffman, who also worked with Ed, will be talking a lot, made great contributions in a number of these areas. In the 90s, with Harris of Harvard, he developed and patented this, as Klaus mentioned, a radiation cross-linked high-density polyethylene that's become the main material for total joint replacement. And in other areas, I'm sorry, let me just go back one. So these are just pointing out, again, the effects of polyethylene oxide, cross-linked polyethylene, and also his work with Clark, who we'll be talking later, led to the first NIH guidelines for artificial kidneys in the 1960s. As I was thinking about how to end the lecture, I was thinking of a particular movie I remember watching, which is called It's a Wonderful Life. It's a movie with Jimmy Stewart. And in the movie, for those of you that haven't seen it, maybe everybody's seen it. It's a good movie to say. But in the movie, there was an angel who showed Jimmy Stewart what his life would. He got kind of depressed, Jimmy Stewart, and so there was an angel that was showing Jimmy Stewart what his life would have been like, or what I should say the world would have been like had Jimmy Stewart not been born. And it was totally different. I mean, instead of the wonderful town that he lived in, a lot of happy people, it was kind of a slum and a lot of unhappy people. And I've always thought that that movie actually provides an interesting test of the impact of an individual. By that standard, I mean, when you look at at these numbers, and far more broadly than these numbers, just really the personal impact that Ed has had on so many people. Because if you take anybody out of the equation, early on, then that takes everybody else out of the equation too, when you look at that standard. So Ed has really just affected thousands and thousands of people. He's touched so many people, and that's actually how they talked about in that movie. He touches one person, that person touches another. And so really when you look at the people he's touched, and the people that they've touched in terms of education, in terms of research, in terms of science, it's truly remarkable. And I think by any standards, in terms of impact, in terms of what he's done personally, in terms of what he's done professionally, it's hard for me to think of anybody who's had greater impact. And and Ed really has had a wonderful life. Congratulations. If people want to ask me questions about what it was like to take classes from Ed, I'm happy to answer those too, but it wasn't really a scientific talk.
So if any of you have those questions, this is the time to ask them.
Yes.
Did he make Alice in Wonderland quotes in your class?
A very interesting question, Lita.
It's coming in the next one.
I think that's coming up. He made all kinds of quotes, so I think you're right, and told all kinds of great stories. But Ed made science fun. He really did. Yes.
Al Michaels used to say, intuitively obvious to the most casual observer. Ed Merrill's class made it intuitively obvious, sort of.
Well, Ed explained things extremely well, and also in a very elegant way. He really had just a. I think all of it was true. Any other questions? Thanks, and Ed, congratulations.
Thank you.